Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 2 on additional expression work. Now in our previous lesson we looked at various terminology associated with algebraic expressions, how to evaluate them, what makes a zero of an expression, what makes an expression undefined, etc. Today we're going to just look at a few more sort of basic ideas within expression work that you want to be comfortable with before we really kind of start to get into the heart of Algebra 2. So let's get right at it. You might want to have a calculator handy for today. It doesn't even necessarily have to be a graphing calculator. I'm going to have my TI Inspire that's going to come out I think just once during this lesson. Anyhow, let's talk about additional common operations. In our last lesson, we examined and evaluated expressions that were mainly polynomial and rational expressions. We should be familiar with other mathematical operations that might arise early in this course, such as square roots and absolute values. So let's start off with some square root work with exercise number 1. Given the expression square root of x plus 10, answer the following questions. Letter A, evaluate the expression when x equals 6. All right, well, we evaluated expressions in the last lesson. Why don't you go ahead and substitute 6 into this expression and determine its value? Pause the video now. All right, let's do it. Here we go. So I'm going to simply put in a 6 wherever there's an x. All right, obviously 6 plus 10 is 16, and the square root of 16 is 4. All right, simple enough. Now, there's a common misconception with algebra and square roots that I want to get into right away. Let's take a look at letter B. Why does this expression have only one value when x is equal to 6? All right. Why doesn't it have two values? All right, so let's get into this right now, right? I didn't say, oh, it's the square root of 16, which is both positive 4 and negative 4, right? All right, that's not the case. So why does this expression have only one value when x is equal to 6? Well, it's because there is no negative in front of the square root. All right, and this is something that's very, very critical to understand. So let's kind of talk about it on the next slide. All right, important square root fact. Although every positive number has two square roots, there's no doubt about it, right? 16 has two square roots, both 4 and negative 4. Okay, because 4 times 4 is 16, and negative 4 times negative 4 is 16. Absolutely. By the way, every number has 3 cubed roots, and every number has 4 fourth roots, etc., etc. Okay? Now you might be like, wow, how could a number have 3 cubed roots? And you might take a look at that by the time you take a class called pre-calculus, which in theory could be next year. Anyway, not the point. Although every positive number has 2 square roots, it's important to note that when a square root appears in an expression, all right, so you're given an expression, the sign of its result is given by whether there's a negative or not attached to the square root. So if there's a negative in front of the square root, like there is in exercise number 2, letter A, well then we're looking for the negative square root. All right. When there's not a negative in front of the square root, like there wasn't in the last problem and also in letter B, then we're looking for the positive root. All right. And this is important because we want an expression to have only one value when we substitute in a particular value for the variable. We don't want it to have 2 values or 3 values or 4 values. We want it to have only one value. Now that's different than when you're taking, let's say, solving an equation and a square root comes in to, let's say, undo a squaring, okay? Then you're likely to get both a positive and a negative answer, okay? But when a square root simply shows up in an expression, whether it's positive or negative, all depends on whether or not there's a negative in front of the square root or not. Let's take a look at exercise number 2. Evaluate each of the following expressions involving square roots. All answers will be rational, meaning that there won't be any irrational numbers. Well, let's take a look at letter A together. Negative square root of 2x plus 11 for x equals 19. All right, let's just do it. So when I'm doing this problem, right, what I'm going to do, just like before, is I'm going to put in 19 for x. All right, I need to figure out what we have underneath the square root. 2 times 19 is going to be 38. All right, now 38 plus 11 is 49, and now literally I'm finding the negative square root of 49, which is negative 7. All right, I mean, it would be weird because if this thing just by itself, right, was both positive 7 and negative 7, then I would have negative positive 7 and negative 7, which means I would have negative 7 and positive 7. In which case there would be no reason to have the negative out front. Like that wouldn't make any sense. And it would be even worse in letter C. We'll talk about that in a bit. Anyway, what I'd like you to do is pause the video now and see if you can figure out what the value of the expression is in B for x equals 4. All right, let's do it. So in letter B, all right, we got a little fraction work going here. I'm going to put 4 in, and I'll have 4 plus 5 in the numerator of that fraction, 4 in the denominator. I'll get the square root of 9/4, and that will be positive 3/2, right? Not negative 3/2, just positive 3/2, right? Because there is no negative sitting in front of the square root. Now finally, see if you can figure out the value for letter C when x is equal to 50. All right, let's do it. So in this situation, all right, we're going to have the square root of 50 minus 1 minus the square root of 2 times 50, which is going to be the square root of 49 minus the square root of 100. Now again, let's pause just a moment before we figure out the final answer here. Again, imagine how crazy ugly this would be if the square root of 49 was both plus or minus 7, and the square root of 100 was both plus or minus 10. We'd have 4 different answers, not 2. We'd have 4. We'd have 7 minus 10, negative 7 minus 10, negative 7 minus negative 10, and positive 7 minus negative 10. I mean, it would just be crazy, right? It would be absolutely insane. You could even argue here we would have a ton of different answers, all right? But here, because square root of 49 doesn't have a negative in front of it, it is simply 7. And here, the square root of 100 is 10, and 7 minus 10 is negative 3. Again, the square root operator in this situation would be nearly useless if it was returning both a positive and a negative answer because of how many different answers we would end up having. All right, let's take a look at exercise number 3, and then we'll move on to a different operation. An object is dropped from the top of a building. The time, in seconds, it has been falling is given by the expression the square root of d divided by 16. Where d is the distance in feet the object has fallen. To the nearest tenth of a second, how long will it take an object to hit the ground if it is dropped from a height of 70 feet? All right, this is simple enough, but it is going to result in an irrational answer, which is why they're asking for our answer to the nearest tenth of a second. But it's simple enough, right? This is the expression we're trying to evaluate when d is equal to 70 feet, right? If we drop it from a height of 70 feet and it hits the ground, then it has dropped a total distance of 70 feet. And so what we want is simply the square root of 70 divided by 16. Now there's no real reason to simplify that fraction or anything like that. What I'd like you to do is evaluate this expression on your calculator, round it to the nearest tenth of a second, and then we'll take a look at it on our calculator. All right, let's bring our TI out. Now, the TI calculator for us is rather small on this screen, and I'm going to have to move it out of my way. It gets in my way. So what I'm going to do anytime I have to bring out the calculator is I'm going to kind of break a little bit out of here. All right, hopefully I'm going to break out of here. There we go. And then let's take a look at this in a little bit of a bigger picture. All right, what I now want is the square root of 70 divided by 16. This is simple enough. I can put in my square root symbol. The TI Inspire is quite nice because you can actually use the fraction bar on it if you so choose. So I can put in a fraction. I can come in like this. I can hit enter. And it looks like to the nearest tenth of a second, it's going to be 2.1 seconds, right? It's 2.09165, etc. But we can say that that is 2.1 seconds. All right. Let's go back in full screen. I don't think we'll need that calculator anymore, so I'm going to leave it hidden. All right, and let's move on and take a look at another operation. All right, well, actually, not true. Let's take a look at a major limit on square roots before we move on. Take a look at exercise number 4. Why is it not possible to evaluate the expression the square root of x minus 7 for x equals 3? All right, what I'd like you to do is try to evaluate this expression when x is negative 3. Go ahead now. All right, well, let's take a look. So if I try to put that in, right, then what I'll end up having is the square root of 3 minus 7, which is the square root of negative 4, which is what, right? Now, look, you can speculate here, right? The square root of negative 4, well, is it negative 2? No, because negative 2 times negative 2 is not negative 4, right? So the only kind of even reasonable answer would be negative 2, but negative 2 times negative 2 is positive 4, so it's not negative 2. It certainly isn't positive 2, because positive 2 times positive 2 is positive 4. So the plain fact is we cannot, at this time, take square roots of negative numbers, right? So we cannot find the square root of a negative number because, let me move this out of the way, any real number squared is positive, parentheses, or 0. Man, the number 0, such an annoyance, right? So I'd love to be able to say the square of any positive number, or sorry, the square of any real number is positive, but 0 is neither positive nor negative, so 0 is kind of this exclusion to the rule. But if you take any other number, right, you take any positive number, square it, you're going to get a positive. Any negative number and you square it, you're going to get a positive. So there's no way at this point in time to take the square root of a negative number. Now watch out, a lot of students will say you can't have a negative square root. Well, no, you can have a negative square root. We just discussed that fact. What you can't do is find the square root of a negative number. So that's precision in language, okay? Never say you can't have a negative square root. You can have a negative square root all the time. Negative square root of 4 is negative 2, right? But the square root of negative 4 cannot be found as a real number. All right, let's keep going. All right, now for our next operator, the absolute value. We should also feel comfortable working with expressions involving the absolute value operator. So let's get into that a little bit. Exercise number 5. Evaluate each of the following expressions involving absolute value. Well, let's take a look at letter A together. A says the absolute value of x minus 10 for x equals negative 4. All right, so let's review a little bit about absolute value by taking a look at this problem. If I'm going to evaluate this expression when x is equal to negative 4, right, I'm going to put negative 4 in here. And the absolute value of negative 4 is simply positive 4. So then I get 4 minus 10, and that's negative 6. All right. So keep in mind, right, the absolute value is the size of a number, right? It's how far it is from the number 0. So when I see the absolute value of negative 4 is 4 units from 0. All right. Now, what a lot of students will remember is if I'm taking the absolute value of a positive number, I just leave it alone. And if I'm taking the absolute value of a negative number, I turn it positive. And that's fine. That gets the job done. It really does get the job done. But ultimately, what absolute value is always telling you is how far a particular number is away from 0, a distance, which is always positive, or you can think about it as the size of a number, right? Which is a little weird because numbers measure size anyway, so it's a little bit strange to talk about the size of a number, but negative 4 has a size of 4. Anyhow, let's take a look at letter B. The absolute value of the expression x plus 8 minus the absolute value of x for x equals negative 3. Well, why don't you go ahead and see if you can figure out what the value of this expression is when x is equal to negative 3. All right, well, let's do it. So, for this particular expression, right, we get the absolute value of negative 3 plus 8 minus the absolute value of negative 3, all right? Negative 3 plus 8 is positive 5, so I have the absolute value of positive 5 minus the absolute value of negative 3. The absolute value of 5 is just 5, and the absolute value of negative 3 is 3. And so I get 5 minus 3, which is equal to 2. All right, that's it. Okay, let's take a look at letter C. Negative 1/2 times the absolute value of t minus 16 for t equals 4. All right, see what you can do on this one, and again, try to do these without your calculator. Pause the video now. All right, let's go through it. So, for this particular expression, I've got negative 1/2 times the absolute value of 4 minus 16. All right, that gives me negative 1/2 times the absolute value of negative 12. That's negative 1/2 times 12. And negative 1/2 times 12 is negative 6. All right, apparently I really liked the answer negative 6 in this problem as I made it the answer to both A and C, all right? Or maybe that's just a coincidence. Anyway, let's keep going. All right, so exercise number 6. Consider the expression the absolute value of x plus 2 minus 10. This expression has 2 zeros. What are they? Justify your answer. All right, so what I want you to do, remember, right, a zero of an expression is a value of x that will make this entire expression equal to 0. Some value of x, and I claim that there's 2 of them, will make this expression equal to 0. What are those 2 values? And I'm not saying you should be able to solve an equation involving absolute values or anything like that right now. I want you to just think about it. What will give us an overall value of 0? Play around with that a little bit. Pause the video now and see what you can come up with. All right, so let's think about this, right? I want this expression to be equal to 0. Now, the only way this expression is going to be equal to 0 is if this expression, right, is equal to 10. That's the only way it's going to happen. All right? Well, how can this expression equal 10? Well, the only way this expression can be equal to 10 is if, well, let's see, I mean, x plus 2 is equal to 10, right? That would get the job done, obviously, because the absolute value of 10 is 10, right? In which case, x equals 8 is definitely a 0. All right, and then just think about it. I mean, if I put 8 up here, I'd have the absolute value of 8 plus 2, which would be the absolute value of 10, which would be 10, and 10 minus 10 would be equal to 0. Bingo. Now, you might think, well, then x equals negative 8 would also be a 0. Except if I put -8 up in here, I'd have the absolute value of -8 plus 2, which would be the absolute value of -6, which would be 6, and 6 minus 10 is not 0. So the other way that we could have a 0 right is if x plus 2 was equal to -10. Right? If x plus 2 was equal to -10, well, then the absolute value would be equal to 10, and 10 minus 10 would be equal to 0. In which case, x would be -12. All right, and those would be our two zeros. All right. Now, sometimes an expression won't have a 0. Let's take a look at that in exercise number 7. Why can the expression absolute value of x plus 2 plus 10 not have any zeros? Now this isn't a typo, all right? Sometimes you'll find typos in my worksheets. This is not a typo, right? Our last problem was the exact same expression, except instead of a positive 10 there, it was a -10, and we had two zeros. I claim this expression can't have any zeros whatsoever. I want you to pause the video and think about why that is true. All right, well, let me write this expression a lot bigger. Okay, well, let's think about this for a second. All right, the only way that this expression could have a 0, the only way, is if this was equal to -10, right? So if the absolute value of x plus 2 could be equal to -10, well, then we would have a 0, because -10 plus 10 would be equal to 0. But the absolute value of x plus 2 must be greater than or equal to 0, right? It has to be, right? Now, it could be equal to 0 if x was equal to -2, but any other value of x, we're going to get a positive value there. So the smallest, literally the smallest value, valley? That was weird. The smallest value of this expression is 10, since the smallest value of absolute value of x plus 2 is 0. All right, so there's no way to have a 0, right? There's no way to even have the number 7 come out of this expression. The smallest value we could possibly have would be 10. All right, let's take a look at one last problem, combining operations. Now, certainly expressions can combine a variety of different mathematical operations, and we've already seen this, right? But let's take a look at one that looks a little bit beastly, but I think we can handle it. Exercise number 8. Consider the somewhat complex expression, the square root of the absolute value of x minus 8 divided by 5x squared plus 4. Now, just looking at this expression, letter A, what is the last operation that would be performed when substituting a value into this expression? In other words, if I gave you a random value of x, I don't know, like x equals 2, and I plugged it into this expression and I started to work through it all, what would be the last thing that would be done? Pause the video right now and write down the last thing that you would do. Well, literally the last thing you would do is find the square root. And that's important, right? Like for me, I look at this and there's no question at all that the last thing I'm doing is taking the square root, because it's kind of on the outside of it all, right? Everything else is under the square root. So the last thing I'm going to do is find a square root. All right. And it's going to end up being a positive square root. So now let's actually do that. Letter B. Evaluate this expression for x equals 2. Do as much as possible and simplify your final answer. Do as much by hand as possible and simplify your final answer. And you should be able to do the whole thing by hand. So pause the video now and see what you get as your final answer. Now, of course, it never hurts to do something by hand and then check it using the calculator. All right, if you're doing it all in the calculator, you're kind of robbing yourself, especially early on in this course, from important review like work with signed numbers, work with the absolute value, work with the square root, and things like that. So I really, really encourage you to do as much as possible early in this course without your calculator. If there's a time when you absolutely need your calculator, I promise I will let you know. All right, so let's do it. All right, for this particular problem, all right, I'm going to substitute x equals 2 in. I'm going to have the square root of the absolute value of 2 minus 8, all divided by 5 times 2 squared plus 4. All right, I can work on both the numerator and the denominator sort of at the same time. I'll have the absolute value of -6 in the numerator. In the denominator, I'll do that squaring first, so I'll have 5 times 4 plus 4. All right, I just can kind of continue working this down. In the numerator, the absolute value of -6 is 6. In the denominator, I'll then have 20 plus 4. All right, then I'll have the square root of 6 over 24. Now, note, right, the square root of 6 is kind of an obnoxious number. It's irrational, as is the square root of 24. But the fraction 6/24 can be reduced into the fraction 1/4, all right? And although both 6 and 24 have irrational square roots, the square root of 1 and the square root of 4 are both very nice, and our final answer here is one of our favorite fractions, the first one we probably ever learned about, 1/2, all right? So, I mean, you probably knew about 1/2 before you knew about almost any other types of numbers, because when you were 3½, your parents were saying you were 3½, right? You know, if you're 5'11½, well, then you're probably rounding up to 6 feet. But anyway, not the point. Final answer here, 1/2. All right, let's wrap this up. So primarily what I wanted to do today was work with 2 additional ideas that are very important in math that you've already been exposed to: square roots and absolute values. All right. We also touched on some important ideas, like the idea that even though square roots or any real number does have 2 square roots, all right, you know, which square root you are going to be using is always dependent on what is showing up in the expression. Is it the negative square root? Is it the positive square root? That will be shown in the expression that you're working with. We also looked at absolute value and reviewed just some basic operations with it. Hopefully those are easy enough. Both square roots and absolute values are going to come up a lot in this course, so make sure that you pay particular attention to this homework. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. Until I see you again, keep thinking and keep solving problems.